I just bought a Subaru Crosstrek. Could have bought a Lambo, but I'm not quite there yet. Welcome to Basic Advanced Math. Today we're going to be continuing the Calc BC or Calc 2 section. Hope you're doing well today because we're doing calculus. It's going to be interesting. Today we're throwing in integration by partial fractions. This is going to be one of the last portions that we go on integrals. However, we got to get through this. We're going to kill it. Let's jump straight into an example. I'm going to show you how to do this, and we're going to kill it. So here's our equation. You can see it's the integral of this fraction right here. You probably don't know how to do this yet, and this is what we're going to get into. So how do we solve this? Our goal of partial fractions is to get this equation into something that we already know how to integrate. How are we going to do that? We're going to simplify this bottom equation by writing it in terms of partial fractions. And I'm going to go over that really quickly. If you already know how to, too bad. So we have this equation right here. I'm going to write it again. So here we go. We have the equation and we have the setup. This is how we're going to be doing it. We're going to be trying to get this equation into a term squared plus another term. If we can get this into a single term squared, we'll be able to use the formulas that we already have requiring an x squared and just plug this in for x. So how do we do this? As you probably already know, if you have an equation like this, to get into the partial fraction form, all you do is if it's x squared plus something x, you half the middle term, divide it by 2, and square it. And you're going to get the third term. Then you have a squared equation, which you can write in this term. So we're going to half the middle term, and we're going to square it, and we're going to see what we have left. Of course, 2 divided by 2 is 1. 1 squared is 1, so that's what we're going to end up with. However, this does not match this equation. So from this equation, you have an extra 1 up here, so we're going to throw out the extra 1 to the side. And you see this is equivalent to this. However, this is a squared equation, so we're able to break it up easily and manipulate it in more ways than we could with this equation. Now, as you'll notice, we already put this into a squared function, so you can pretty easily derive that x squared plus 2x plus 1 is x plus 1 squared, and that's the function that we're going to have in the parentheses over here. And then this extra 1 over here is going to simply go out to the side because we're just throwing it over there. It wasn't part of the equation that we ended up with. So it's going off to the side, and we're going to use that later when we plug it into an equation. So we've broken this into partial fractions. We've got it in an x plus 1 squared, which is much more useful than this one because we have one term squared plus 1, and we're going to plug that back into the main equation, and you're going to see how it's useful for us in just a second. Here we go. We plugged it back into the main equation down here. What are we going to do from here, you might ask? This is where you got to bring everything together. Everything that you know about integrals, everything you've learned, all the rules and equations that you've learned, you got to have them on hand. So you'll be able to take an integral like this and write it in a better way so that you can solve it. As you'll notice, if you remember one of our previous episodes about trig integrals, that this right here, 1 over 1 plus x plus 1 squared, is in the arctangent form. If you were to replace this x plus 1 with just x or u or a single variable, the integral of that would be the arctangent of x. However, you don't have just x or u, you can substitute it in. This is where we're going to use substitution. We know that we want to get x plus 1 squared to x squared, so we're going to set x plus 1 equal to u, and then we're going to plug u back into this equation, and that's going to be it. So we made a substitution. We have u right here because we want this to equal u, so we can plug it into the equation. We're going to solve for du. We have du equals 1 dx, which is super handy. It's going to be easy to use because they're equivalent to each other. We won't have to make any other alterations to this equation to try and make it fit du. Okay, so now what do we have here? We have u in place of here, du in place of here. We're going to rewrite this with the substitutions in place. So we have this equation right here. We've made the substitutions. This is what we have left. The integral of 1 over 1 plus u squared. Now, based on your trig formulas that you already have, we know that this integral right here is equal to the arctangent of u. So we're going to go ahead and integrate it, and we're going to get arctangent of u left. We made the integration. We have arctangent of u plus c. We're almost done. We just have the simple last step to plug the x back into this equation. And this is going to be our final answer. We come up with arctangent of x plus 1 plus c, and that is the basics on how to use partial fractions to solve an integral. Obviously, they might get more complex than this, they might get simpler to this. You got to be able to use the rules that you already know and the basic stuff that you already have to be able to combine different methods to solve integrals. You got to get down how to solve the partial fractions first. Once you get that down, everything else will come easily. It's just recognition and plugging in. Other than that, don't forget the plus C. There's nothing left. I believe in you. Do well.